All right, so hello everyone. Welcome to our presentation on URIEL Plus, where basically our team managed to take a very highly cited knowledge base in multilingual NLP and computational linguistics called URIEL, and managed to enhance it into URIEL Plus with the intention of making it more usable and also making it more inclusive in terms of language coverage um, in typological sense. And the idea here is that we show that increasing inclusivity of languages, adding more data, has benefits in terms of downstream tasks as well. And we'll kind of be talking about that throughout this presentation. All right. So in terms of the contents of this presentation, we'll start off with a quick kind of introduction towards what URIEL is, and some of the flaws with URIEL in particular. And then after that, we'll talk about how in URIEL Plus, which is our contribution, we managed to improve upon those flaws. And in particular, we talk about things like how we add more information from different databases into URIEL Plus. And in particular, we also talk about how using that data, we make improvements to the distance calculations that you can do on that data, and in particular, its reliability and rigor. Following that, we validate each of our improvements to show that they are indeed actually improvements, and then we conclude and talk about a brief bit about the future work that we intend to do. All right, so let's briefly talk a little bit about URIEL and LangCheck. So URIEL is basically a knowledge base where the idea here is that you represent languages as vectors. And there are different types of vectors within the knowledge base. There are typological, or a synonym for that would be featural vectors. There are genetic vectors and geographical vectors. Usually when we talk about vectors from the URIEL knowledge base, we talk in particular about the typological vectors. And these kind of vectors are binary vectors in the sense that if you have a language and it's represented by a vector, say the ith entry of the vector would represent like 0 or 1, depending on whether the language has or doesn't have a particular language feature. Um, and the idea here is that if you can represent languages as vectors, then you have a numerical representation for them, and you can obviously compute distances based on those vectors. So computing a distance on those vectors serves as a proxy for the distance for the language as well. And you can use lang2vec to query the URIEL knowledge base to obtain these distances. And these distance calculations are pretty useful for downstream tasks in multilingual and cross-lingual NLP works. I believe at the time of recording this, there are about 250 or so citations of URIEL, so it's pretty highly cited. But the problem here is that URIEL has some flaws in it that make it kind of not as reliable as we would like it to be and not as usable as we would like it to be. And some of these were identified in a reproducibility study done by Hasty Tusi in 2024. So one of the biggest kind of problems within URIEL is that sometimes the distance calculations don't really match what we would expect the calculations to be. So I would encourage you to look at the blue box on the screen right here, and this is kind of representing the distances that URIEL plus would report versus what URIEL would report. URIEL is not bolded for Croatian and Serbian. So notice that Croatian and Serbian has a reported typological distance or equivalently featural distance of 0.9. Now, the higher your distance value is, we say that the more distant that they are. This should immediately raise some eyebrows because Croatian and Serbian are generally pretty close languages to each other in terms of their typology. Some might even say almost the same, right? So the fact that the knowledge base is saying that they're basically the same is kind of a problem. Now, URIEL Plus kind of improves upon this. We basically report them as having almost basically the exact same kind of typological features. We report a distance of exactly 0. So that kind of shows that, yeah, Croatian and Serbian should be almost the same typologically, and we kind of reflect that within the URIEL Plus knowledge base, which is our contribution. Um, yeah. There are other kind of places where URIEL has some flaws. For instance, there's low feature coverage. By feature coverage, we say that a language is covered featurely if there exists at least some data, some typological data for that language within the knowledge base. Now, if you take a look at the graph on your right, you'll notice that if you look at the red bars in particular, almost 73% of languages don't have any kind of phonological data at all. Two-thirds of languages have no inventory or phonemic data at all, and a third of the languages have absolutely no typological data in the URIEL knowledge base, and that disproportionately impacts low resource languages and in particular, which kind of harms its usefulness for them. So yeah, there's quite a bit of lacking feature coverage within the knowledge base. There's also no morphological data at all, so you can't really compare languages on the basis of morphemes, which is a very big comparison point that is missing, particularly when the data is available in the literature, for instance, with GramBank. And a third kind of problem is ambiguous kind of distance computations. Now, a big use case of the URL knowledge base is that since you have vectors representing languages, you can compute distances between those vectors, giving you kind of a numerical representation of how distant languages are, right? We saw an example with Croatian and Serbian in the previous slide. Now, the problem here is that if there are no kind of comparable information within um, the vectors in the URL knowledge base, you shouldn't be able to compute distances on them if they have no comparable information, like if it's like completely missing, for instance, all the data. However, URL uses default values without the user's knowledge. That is something that was identified within HAST-T2C's paper in 2024. And that's a problem because if you're not telling the user that you're doing that, that basically gives the user a false impression of the distances between the two languages. And not only that, the distance metric is often unclear within the documentation. For instance, some documentation will say that they use angular distances, others will say cosine distances. So there's a bit of unclarity with respect to that as well. So in URIEL Plus, we have, I guess, three contributions that we can talk about, A, B, C. We have integration of more databases into the URIEL Plus knowledge base. What this means is that remember that we have like feature vectors, for instance, for each of the languages. Now, feature vectors source their information from different downstream upstream rather databases. So for instance, SSW, walls, etc. Right? Now we incorporate data for new databases into URIEL Plus, which should increase the amount of feature coverage for many languages. Now using that, we have a number of different improvements that we discuss in Part B. For instance, we have feature coverage improvement. We also talk about the fact that we have more data, that we have an imputation module, and on those data, we can compute more robust distances. We discuss all three of those. And finally, we verify it in particular with a imputation, or rather with looking at downstream tasks and how URIEL Plus performs with respect to URIEL, and we show that there are actually benefits in terms of downstream task performance with our new data and our improvements. So let's quickly talk about the linguistic resources that we added into URIEL Plus. There are four completely new databases that are incorporated into URIEL. The first of these is BD Proto, so this has data for ancient and reconstructed languages. GramBank added morphological features for over 2,000 languages. And if you recall, this was one of the things that was missing within the original URIEL knowledge base. Apix and eWave add data for Pidgin, Creoles, and dialects. And altogether, this expands typological coverage for almost 3,000 languages, which is quite a lot. Now, not just in terms of like typological coverage, we also have 361 completely new languages that are represented within the URIEL knowledge base. And a lot of these are low resource languages versus Pidgins, Creoles, etc. And altogether, this leads to quite a bit of feature coverage improvement, and this is uniform across all resource levels. In particular, take a look at the blue bars. Blue bars represent the amount of language that have some kind of coverage within URIEL Plus, as opposed to red. And you'll notice that, particularly for if you take a look at like low resource languages, syntactic and phonological features, almost 1,000 new languages each have data. You can also see that the morphological features are completely new. So that's a big kind of improvement. This is across all resource levels. You can see this kind of an improvement. Now, we also make improvements to distance computation. So for instance, we have more robust distance computation. So what does this mean? Remember that we had, a problem with there was lack of like documentation, for instance, in terms of what distance metric was used with the URIEL knowledge base. We now allow the user to choose between angular and cosine distances. And if you recall, there was also a problem where they would use default values if there wasn't like sufficient data to compare languages. But now we just disallow calculations when there are not sufficient data. And this kind of addresses some of the ambiguities within URIEL. Now, to make up for the fact that there are still kind of some missing data within URIEL Plus, we have integrated imputation algorithms. And of course, it's a good thing because if you have accurate imputation, that means that you have more information or feature data to compute distances on. And finally, we have confidence scores. So one of the big problems within URIEL was that we would like report distances, but you wouldn't really know how confident you could be within those distances. So we have confidence scores that we also report within the URIEL Plus knowledge base, and this kind of guides the user towards like how confident they can be between the distances between two languages. So, for instance, one of the confidence scores that we talk about is, or that we report, is data completeness. So obviously, if you have more missing values, you have less kind of data to work with to compute distances. So in principle, you should have less confidence in the distances that you compute. In other words, the more complete your data is, the more confident that you are. We also report, for instance, data agreement. So remember that the URIEL and URIEL plus knowledge base by proxy sources its information for its vectors from a bunch of different sources, a bunch of different databases in particular. And in particular, two different databases could disagree on whether a particular language has a feature or not. Now, if you have more disagreement amongst different sources, then that means that you have less kind of confidence, per se, in the kind of features that you have, or the feature data that you have for a particular language. So if you compute distances on that unconfident data, your distances themselves will be kind of um, not as reliable, right? You can't be as confident in them. So in particular, this means that if you have more agreement, data agreement among sources, then you have more confidence in your distances. So we report a kind of measure that talks about how much data agreement there is as well. And finally, if you impute your data, then obviously imputation quality kind of matters a lot as well. So we report a metric that for imputation quality as well. Now, we have all those kind of improvements. It kind of remains to actually validate URIEL Plus on them. So we compare URIEL Plus against URIEL for NLP tasks by kind of comparing the distances or computed on the vectors in these knowledge bases, or alternatively, the vectors themselves. And we tested it on three very common NLP tasks. So the first of these is proxy LM, which is a performance prediction task in particular. And it uses URIEL typological distances within the regressive framework. So we kind of compare URIEL and URIEL plus distances to see which gives better performance within this task. For LangRank, the idea here is that you want to find the optimal kind of transfer language for cross-lingual transfer, and they use URIEL language features for that task. So we kind of compare URIEL Plus and URIEL on that. And Lingua Alchemy basically uses a loss function to fine-tune multilingual NLP kind of models, for instance, like MBERT for different tasks. And we kind of compare the URIEL vectors against URIEL plus vectors in the loss function that they use. So comparing URIEL against URIEL Plus on each of these tasks, we see improvements in basically all of the tasks except one. But even in that one where we see a performance decrease is basically negligible. And amongst the improvements, almost or the majority of them are statistically significant. So the idea here is that we achieve comparable performance, which with quite a bit of increased feature coverage as well. So yeah, we definitely get like better performance overall. So the conclusion here is that with URIEL Plus, we have expanded typological coverage for almost 3,000 languages, and we just in general support 361 new languages as well. We've made our distance computations a lot more reliable and robust, and we've provided confidence scores for them so you, the user, can figure out how much you can trust each of the distances. And we've also shown that we increase performance on downstream tasks as well. Now that we do have some future work, so for instance, we are planning on incorporating information on language systems for each of the languages. Now, this might not necessarily reflect how the languages themselves are spoken, but it does give some kind of information for each of the languages as well. It's another comparison point, I suppose. The idea is to kind of include information from script source. The second piece of future work is that we intend to use PCA to kind of remove non-contributing features to particular distance computations, and the hope is that this should reduce the amount of runtime it takes to complete the distances. And finally, we plan to have a web interface as well for our work to kind of connect researchers with the most kind of relevant data for their work as well. All right, thank you so much for listening. If you would like, you can scan the QR codes as well to kind of see the paper or the code. Thanks.